We want to find the domain and range of f of x equals the square root of x squared minus 4. We know that we can't have a negative under the radical because the square root of a negative would not be a real number. So that x squared minus 4 has to be greater than or equal to 0. This is an inequality that we can easily solve for x. Okay, this is a quadratic inequality, and one method of solving a quadratic inequality is to factor. We start to factor and we get x minus 2 times x plus 2 greater than or equal to 0. Now, this says that this times this is positive. The only way that can be is if both this and this are positive, or if both this and this are negative. Okay, well, if they're both positive, then we have x minus 2 greater than or equal to 0, x plus 2 greater than or equal to 0. Gives us x greater than or equal to 2 and x greater than or equal to negative 2. Now, if x is greater than or equal to 2, then it's certainly greater than or equal to negative 2. So that this inequality covers this one. This inequality, though, can be true without this one being true. X could, for example, be negative 1. Okay? Negative 1 is greater than or equal to negative 2, but it's not greater than or equal to 2. So we can see that if we put this together with this, we just get this. The first condition covers the second. The second has solutions that aren't in the first. Any solution of the first is a solution of the second. There are solutions of the second, they're not solutions of the first. Therefore, these two inequalities combine to give us just the first. The x is greater than or equal to 2. Okay, now, these could have opposite signs, okay? So that x minus 2 could be less than or equal to 0, and x plus, I'm sorry, they couldn't have opposite signs. They could both have negative signs. Okay, they could both be negative, meaning both could be less than or equal to 0. Okay, x minus 2 less than or equal to 0 means x is less than or equal to 2. X plus 2 less than or equal to 0 means x is less than or equal to negative 2. So again, if this is so, then this is so. If x is less than or equal to negative 2, then certainly it's less than or equal to 2 because 2 is bigger or greater than negative 2. So there are solutions of this that don't satisfy this, but there are no solutions of this that don't satisfy this. All the solutions of this satisfy this. Therefore, when we combine the inequality, we get x less than or equal to negative 2. Now, we could either have the condition that both of these factors are positive, which comes down to x is greater than or equal to 2, or they're both negative, which comes down to x is less than or equal to negative 2. So that we have this combined solution, or this combined description of the range, all the set of all values of x that are less than or equal to negative 2 or greater than or equal to 2. And we could express those in interval notation. Set of values less than or equal to negative 2 is the interval negative infinity to negative 2, and the values that are greater than or equal to 2 would be the set, would coincide with the interval to infinity. There is an error here. I should have had closed brackets on these two. Let me fix that. Okay, not particularly pretty. I had to use closed brackets there. Okay, to get the range, one thing we know for sure about the range is that the square root of any number has to be greater than or equal to 0. And that's, well, again, this, so and specifically, the square root of x squared minus 4, the expression we're considering, has to be greater than or equal to 0 because any square root has to be greater than or equal to 0. Now, this doesn't assure that we could always find an x for any number greater than or equal to 0, and the range only consists of the numbers that could come out of this, that could be the result of this calculation. So the question is there always, for any number greater than or equal to 0, is there always a value of x that gives us that number? Or alternatively, are there any numbers greater than or equal to 0 that we could not get from this calculation? Well, let's let y equal square root of x squared minus 4. Okay, so y is something that can come out of this. We're going to solve this equation for x. Okay, so if y is a square root of x squared minus 4 for some value of x, then clearly y squared has to be equal to x squared minus 4. Which means, of course, then that x squared has to be y squared plus 4, and x then has to be plus or minus the square root of y squared plus 4. Now, we can solve this for any positive value of y that we want to put in here. So this exists for every positive y. Now, I've got something incorrect written down here. I want to correct it, and then I'll go on. Okay, this is not written down particularly well, but I can say that this x exists for any y greater than or equal to 0. Actually, it could exist for any y at all, but we already know that y has to be greater than or equal to 0 since y is a square root. So this exists for any y greater than or equal to 0, and we've confirmed then that for any positive or y or 0, we can find an x that gives us that y. That tells us then that the range has to consist of all values from 0 to infinity.